this. Now we can actually have symbols for it. Let's go ahead and try to do an example that we've had like probably 5 times, but just so you get the symbols down. We've actually done this problem. I think we've done it, I've had it on the board several times, we've actually done it twice. The integral of x squared dx says, I want the antiderivative of this function. What's the function? With respect to the variable x. That should match up. That has to match up for you to do it, okay? You can't do it if it doesn't. At least not with our single variable calculus that we're doing. So if we're doing an integral of x squared dx, we're going to find the antiderivative of x squared. Okay, so we have that. Yeah, that's the 1/3. Or x cubed over 3 is fine. That doesn't quite do it yet. We also have to have, it's crucial, you've got to have that, plus c.
Oh, minus c, right?
Well, if you had minus c, you could write that as plus negative c, right? So you're always going to write plus c. So c is just some arbitrary constant that can stand for anything. That's how you do most of these problems right now. You kind of find it says antiderivative of this function with respect to that variable, and we know how to do at least one of them, right? So right now what I'm going to do, I'm going to give you the basic integration table. Listen, if it doesn't fit in the basic integration table, you cannot do it right now. Okay? You can't create your own calculus here. If you do, you're better than Isaac Newton, who invented this stuff way back in the day. That day was 1600s. So probably not going to happen. So don't invent this. Just follow the table. You do have to memorize it. I'm not going to put this on the board, but trust me, you will. The only tough ones are really the some of the trig ones that I'm going to give you right now. Some of the trig integrals are to memorize. But think of it this way. You already know the derivatives, right? We're just undoing them. So that's where all this stuff's going to come from. In fact, the table I'm about to give you is going to have the derivative and then the integral that's associated with it. You ready for it? Okay, so.
This is like the integration table?
Yeah, basic integration table. You know, there's a lot of them. There's a lot of integration tables. Yeah, most of the back of your book has just all those weird pages, right? What are all those? The curvy things. Someone had fun just scribbling. No. Those are integrals, and they mean something, right? They all have different formulas. This long, what is that thing? It's integral, but what does it look like? What letter? It's an S, and what we're going to come across in section 4.3 is that that's actually a sum. This is going to blow your mind. But remember how I told you that you can add all the rectangles together? That's what you're doing. It's a sum. It's a sum. That's where the dx comes from. I'll show you all this. I'll make it very clear to you as we get there. But this is what we're doing. This is a way that you're adding all the infinite rectangles together and getting an area. You get it? Kind of cool. Kind of cool. It all makes sense in a little while. So basic integration table. Like I said, I'm going to start you off with the derivatives, and we're going to come up with the integrals that are corollaries of them, because we know an integral. So if we know the derivative, we should be able to somehow manage to get an integral out of that. So let me ask you this. What's the derivative? We'll start very simply. What's the derivative of x with respect to x? Derivative of x is simply 1. Derivative of 2x would be 2. 4x would be 4. So the derivative of x is 1. What that means is this. Hopefully you find out what I'm going to do here. What's the integral of 1? What do you think? If the derivative of x is 1, the integral has to undo a derivative. That's what this says here. A derivative undoes an integral undoes a derivative. So they have to go in reverse. They're like inverse operations like division, multiplication, just square and square root. Same idea. So if the derivative of x is 1, the integral of 1 is x. Sure. Why? Think about it. You're undoing this like it's a derivative, right? That means if you take a derivative of this thing, it should hit it. No, we're missing something here. Plus c. You okay with this so far? Okay. You know, let's do this in general.